those regions. And now it's not mine. Okay, let's okay. I see that now. You see the color now? That's the color change. Let's come closer. So I just want us to see. Look at this. Look at this. You can see. Hello guys. You are welcome to today's class. I want to believe you guys are doing very, very fine. Now, let me quickly say congratulations to my WAEC students all over the globe. You know, it was a successful exam, and we thank God for the predictions here. It was wonderful, it was marvelous, it was exciting. For everybody that has reached out to me, that has said a word of prayers, for the encouragement, for the motivation, I want to sincerely thank you guys. I wish you guys tremendous success, and Chemistry Hangout loves you people. I love you so, so much. Very quickly, for people that are writing NECO, you know, I've said that we're going to be doing all our best to make sure that learning and teaching here is fun, and it gives us this confidence for our exams. I'm going to be saying a lot of things. I'm going to be doing the titration for this year exam, and I want you to pay maximum attention. I'm going to say something as regards the alternative B2, and that's why, you know, when I give a particular predictions, I explain in so many ways, so that if it comes like this, you know exactly what to do. If you remember, I always say that we are not saying this is the 100% question, but if you follow the teachings here, you should be confident of 75% of what is coming out on that day. And that's the reason why we are doing all these things, to make sure that we are confident. So, okay, so very quickly today we're going to perform the practical. We're going to look at the predicted questions. I'm going to solve a whole lot of questions, so stay tuned while we have a wonderful experience again in chemistry today. If you are just watching this channel for the very first time, you're welcome to Chemistry Hangout. We love you. This is a place where teaching and learning is fun. Okay, if you have not subscribed to this channel, kindly click on the subscribe button and turn on the notification bell, so that when we upload the video, you would be notified. We'll still be coming up with the qualitative analysis. Very interesting. It's another very interesting organic test this year. Very wonderful, very interesting. We are still going to be coming out with that. But for today, we are doing the titration very, very quickly. So, of course, we have the predicted question for this year. We have the predicted question. A is a solution of 3.35 grams in 500 centimeter cube of H2SO4. Now, let me quickly say this. You know, I saw the alternative B questions, and it was funny, because there was a lot of panic, and I've told you. Let me quickly say this to my chemistry educators. Please, if you have gotten a title value, irrespective of the question on that day, stick to your title value. Look at this. If you remember, if you have been following my channel, you remember I did something like this on that day, that if the question comes like this, for people that have been following, I did something at the end of the video, if you remember. You know, I said the question can come like this, okay? And they can ask you to look for what? For X. But what they did was that the question came like this. Do you see that? So the question came like this. Now, if the question comes like this, a lot of teachers need to alter their values. They were, you know, they were manipulating, they were altering their title value to make sure that the value of X is 10. The value of X may not be 10. That is why it is X. X can be any number. Because the value of X will now depend on the title value you have used on that day. I don't know if you are getting it right. Because this is what you actually prepared. For teachers, this is what you prepared. We prepared an anhydrous salt. But they came in the question and gave us an hydrated salt. They know what they are doing. So because what WAEC actually do most times is they are marking your steps. Not really because they want you to get X to be 10. Because they know they gave you an anhydrous salt. So there is no way that they want accuracy when it comes to this question. What they are just marking is, do we understand the process? So if you are taking this exam too, for NECO students, you are taking this exam, the question can come like this too. Because what they gave us to prepare is an anhydrous sodium carbonate. Can you see? But if the question, maybe the question comes like this, or the question comes like this, or the question instead of H2SO4, what they gave you is X2SO4, or what they gave you is H2S. You can see the question can come in many ways, but these things are still saying the same thing. Come closer, let us look at something. This is X2CO3. Don't forget that our X, is Na2CO3 that we prepared, right? This is Na2CO3.XH2O, meaning they are looking for a particular, water molecule here, the number of, water of crystallization here. So they are looking for the number of, the amount of water that you have here. Alright? Now look at this H2SO4. They said H2SO4, meaning they are likely to look for this. Look at this H2S. Do you see that? The H2S normally is H2SO4. I just did something like H2SO4, I removed the H. And I'm just giving you ways question can come. See, for all these questions that are here, for you to be able to do anything here, you need to get the molar mass. And we have said that mole is equal to mass over molar mass. So because of the X that is here, 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 you cannot calculate the, you cannot get the molar mass directly. So you need to use this formula, mole equal to mass over molar mass. Making this the subject of formula, you now have molar mass equals to mass over mole. I don't know if you are getting that. So at the end of the day, when you use it, because in the question directly or indirectly, they must have given you the mass and you must have known the mole. So when you divide this, you are not going to get a value. Okay? Maybe 300, maybe 286. Do you understand that? So if the mass, the molar mass of this one is now probably 106. Can you see that? So you are looking for X now. X times 2 plus they would have given you carbon 12 plus 16 times 3. This you just do your number equal to 106. Do your normal arithmetic. For this one too, it's still the same thing. Since we are looking for X here, they would have given us this 23 times 2 plus 12 plus 16 times 3 plus this is X now. X, right, equals hydrogen 1 times 2 plus 16 equals to the molar mass that you have gotten. So at the end of the day, you will see that you only have X here, then you can equate and get the value of your X. So that's where question comes. But then a lot of teachers reached out to me. I was like, the value is supposed to be 10. If you have gotten 10 on that day, I'm not saying you are wrong, but if you have not gotten 10, you are still right. Because the value of your X without, depends on the title value that you have used. But some of us, we are just manipulating. That's why these things are practical. We take our time here to do all these things. You have gotten your title value before the exam. Because you saw the question, you are altering your title value. It's not supposed to be so. Because what they have given us to prepare will determine what our title value will be. So don't let the question determine our title value. We have prepared our solutions like this. We have done the titrations. Let's stick to our title value. Most of the time, they are marking our steps and not really what we suggest or we assume to be the answer. Some of us as educators, we already have something in mind that we want the answer to look like. So when it's not looking like the answer, we feel we are wrong. No. It is the titration, it is the experiment that determines what the answer is going to look like. Not the other way around, not the way we feel, not our assumption or our subjection. So please, I just want to quickly correct that. So for alternative B, if you have gotten your X to be 10, you are correct. If you have gotten your X to be 18, you are correct. If you have gotten your X to be 23, you are correct. Because it depends on the title value you have used on your center. So if the title value you have used correlates with what your teacher has put in the report, no matter the value of your X you got, so don't panic. I hope I've made a whole lot of points, so don't panic. Let's just understand how this is. So the questions can come, in anyhow like this. Anytime you see X in the question, just know that you have to get the molar mass of that compound first. Then you can now equate and get the answer. So I just have to keep that in. The question can come like that too. That's the reason why I take my time to emphasize on all those things. These are predictions. We cannot do 4 or 5 predictions in a video. You should understand. We cannot do 4, 5, 6 predictions. No. We just pick the one that we feel is the best, then we do it. So you too, you sit down and explore other means too, and that makes you a good student. So let's get started. So we'll do the titration very quickly, but let me have my table first. I'll just do the titration once. If you have been familiar with this channel, you should understand how titration is being done by now. So I'll just do just one of the titration. That's what I will do because of our time. Okay, so I'll just do one. So the rough in centimeter cube. So this is my table. The first in centimeter cube. Then I can have the second also in centimeter cube. I hope this is clear. So from there, I can have my final readings. Okay, right? My initial readings. Okay. So from here, I can roll this. I can roll this. I want to believe this is clear. So from there now, if you have all this, okay, if you have all this now, the volume of our pipette, most times they will always tell us to record it. Very important. So for most of my titrations, the volume of my pipette is this. An indicator, I'm going to be using methyl orange. So I'll use methyl orange. Okay, so let's get set. Let's quickly do the titration. Let me quickly review. Just doing it once, we are almost familiar with titration. Most times we do it on this channel, so it's now very easy. And a lot of students have reached out to me that their titration skill has actually increased. That's wonderful. I love that. I love those feedback. It helps us to, it encourages us that people are really getting what we are doing. So I'm filling to the 0 mark so that I can just run 1 or 2. Okay. So let me run little out just to get there, Run little out. Okay, so from there, I hope it's not entering here. Let me rinse this. Okay. So from there, what do we do? Let's quickly pipette this. We're familiar with that. So let's pipette this. This is my base that I've prepared. That's why I labeled this A. Is this A? Okay. So this is the acid. I'll label this B. You can do that too in your various centers for teachers. Okay, so 25, and it's in my conical flask. I want to believe this is clear, so just quickly do that. You're familiar with titration already. I'll be doing that. Okay, so from there, this is my methyl orange. I'm putting 2 drops, 1, 2. And look at that, a yellow color. So let's start our titration now. And bring this here. So let's begin our titration. So that I can see the readings. Let me. Okay. Okay. So that I will see those readings. I will not waste our time. I want to believe you're still here, so gently. Okay, let's go gently. Okay. Can you see that now? You see the color now? That's the color change. Let's come closer. So I just want us to see, look at this. Look at this. You can see this is 20. You can see this is 20. Okay. This is 20.567. Please let them so that we can see that well. You can see. So this is 20.5. You see that now. So let's say 20.6. 20.6 over there. Okay, so you can see this 20, this 20.5. Let me take the lower menu score, so 20.6. Do you see that now? So the reason why I'm doing this is because to always show us that it's not like we are just running practicals and we are just picking title values. When you prepare the right reagent, we are not saying the theoretical value should be accurate with the theoretical value. But if you have prepared your reagent well, that's the first step as a chemistry educator, preparing the right solutions, preparing it accurately. It will give us an endpoint closer to either the theoretical value we are used to or what we actually want to use. So I'm just doing it for once. Of course, we are familiar with titration, so that we can go. So I can just say this is 20.60, right? Like what we got. Okay, so I can add this to the. Since this is rough, I've given us that technique. I know I'm not using this, so I can just a bit. I can just take it higher a bit. I don't know if you're getting that. So I'm interested in this because that's what I'm using. So I can just use my initial reading to be 0.00, 0.00. I hope you get that now, because I don't want to keep titrating, because of our time, and we understand the titration. We have seen the color change. You get that now. So, and we have shown us to see 20.60. Okay, so and in various schools, some people will get 20.5, some people can say it's 20.6, some people will get 20.7. It depends on how much the accuracy, and it might differ. There is no problem. 20.5, 20.6, 20.7, we are still within that range. I hope that's clear. Okay, so from there, we can now have volume of acid used. So we subtract 20.60. Do you get that now? Imagine on that day, a teacher that have done the practical, students have done the practical, and we got 20.60. How do you want us to change it on that day? Because of the question we have seen, no. That doesn't show professionalism. I don't know if that is clear. I have done the practical. I have prepared the right reagent. This is the H2SO4 they asked me to prepare. This is the sodium carbonate they asked me to prepare. I have prepared it well. I have prepared my indicator and I have titrated. And this is the value I got. So there is nothing that should change this value on that day. Changing this value on that day means I am not sure of the title value I got, which is a bit not professional. So irrespective of the question on that day, this is what I'm using. In your school too, you can use it too, it's fine. You can do your titration to stick to your title value. It gives us this confidence that we are on the right track. I want to believe that is clear. So from there, we can close our table, right? So from here now, what do we do? We can now calculate the average volume of acid used. I'm taking these two now. So that will be 20.60 plus 20.60, right? Divided by what? 2. So at the end of the day, the average volume of acid used is going to be 20.60 centimeter. I want to believe this is very clear. Okay, so these are the way we do all these things. These are the way we do all these things. So very important. Now let's now move to the question very fast. Let's move to the question very fast. Okay, so question 1 now. Question 1 says that from your results and information provided, calculate the concern. We have done this, tabulate your readings and calculate the average volume of acid used. That's what we have done here. So sorted. So number 1 says, if you are used to this channel, there are some things you should know how to. We have been solving concentrations for the past, few years now. So you should understand this. That's why you should be able to explore other means. Okay, let's go now. Concentration of A in mole per DMQ. Let's go to A. Now look at that. A is a solution of 3.35 gram in 500 centimeter cube of H2SO4. I've always said that on this channel that the standard measurement in the chemistry laboratory is what? Is 1000 centimeter cube. So anytime you are solving in chemistry, you see in 250, in 500, in 750, in 950, you have to convert back to 1000. If you will not convert back to 1000, look at this one now. B is a solution of a hydrosodium carbonate per DMQ. Per DMQ means 1 DMQ. And 1 DMQ is the same as 1000 centimeter cube. So if you have given me any figure here, any mass here, there is no need for me to convert again because it's already in 1 DMQ. But look at this. is not in 1 dm cube. So if A now is in per dm cube, I don't need to convert again. I can use the mass like that. I want to believe that is clear. So, but now, so on that day, if A is in per dm cube, I don't need to convert again. I can just use that value. I hope that's clear. So, but if it's in 500, 250, 750 in any value, I convert to 1000. So let's go now. So we have that the first question, number 1. So from the question, we said 3.35 gram is in 500 centimeter cube. Okay? So 1000 centimeter cube will be what? Will be x, right? So x will be this times this. That will be 3.35 times. Use my calculator and see what x will give us. So we have 3.35 times 1000 divide 500. So that's giving us 6.7. So I can just say 6.7 gram per dm cube. Can you see that now? So if they have given us this before in the question, I don't need to convert again because it's now in gram per dm cube, meaning 6.6 gram in 1 dm cube, which is 1000. But if it is in 500, in 750, in 250, I need to convert. Note that. So I can now calculate the concentration of A in mole per dm cube. You see, the questions are clear. They said calculate concentration of A in mole per dm cube, not in 500 centimeters. So I need to convert. So from there now, I can now say my mole is equal to mass over molar mass, right? So what is our mass? We have gotten that already. Molar mass of H2SO4. So molar mass of H2SO4. So let's see that now. This will be 1 times 2 plus 32 plus 16 times 4. All these one will be given here. You can see hydrogen is 1 times this 2 plus sulfur, that's it, 32 plus oxygen 16 that has been given times 4. I hope that's clear. So from here we have 2 plus 32 plus 16 times 4. That will be 64. So let's use our calculator. 64 plus 32 plus 2. And that's giving us what? 98 gram per mole. Please, the units are very, very important. So from there, we can now apply this now. So our mole is now going to be 6.7 gram per dm cube over 98 gram. So you know you're on the right track. Gram will cancel gram. So what is remaining? Mole per dm cube. So our mole is now going to be 6.7 divide 98. And that's giving us 0.0684. So 3 significant figure mole per dm cube. Sorted. I want to believe this is sorted. This is sorted, right? Very clear. I want to believe this is very clear. So let's move now. If you have been watching my videos, that's the reason why, please, I want us to take our time to watch these videos so that we can exploit other means. Okay? And that's the reason why if you want to solve questions like this, if you see questions on H2SO4 and sodium carbonate, you can solve it. The only thing is that you just change the titer value they used and use this by titer value and still solve. So please, all these things they are very simple. All these things are very, very, very simple. Let me take this away from this place so that it doesn't obstruct the board. Okay, so that it doesn't obstruct the board. Get that now. Okay, thank you. So let's go now. From there, we can now say, look at that. I said this in my last video. Can you see? Again, amount of Na2CO3, which means if they have asked us concentration of Na2CO3 in mole per dm cube, what are we going to use? CAVA over CBVB equals to Na over NB. If they have asked us concentration, which can be asked on that day, concentration of B in mole per dm cube, if they ask that, you know they didn't give us any mass. So we cannot use mole equal to mass over molar mass because the mass of this is not given, right? And we cannot be calculating molar mass same time, so we cannot use this. We come to this. That is, if they have asked us concentration of B in mole, but they didn't ask. What did they ask? They asked amount of Because if you have asked concentration of A in mole per dm cube, if I use this, I'm correct. The Ca, that's what I've gotten, right? The Va, that's the titer value. The Cb, that's what I'm looking for now. The Vb is what? 25. The Na, they have given me the equation of reaction, 1 to 1. You know, that's the reason why sometimes this equation of reaction is important. They can ask you to write it. The last exam, they ask them to write the equation of reaction. So, not all these things, they can give you, they can ask you to write it. So, if you just be 1 to 1, you know, from there now, I cannot get my CB. But the question is amount, it's not on constant. So, you can do that yourself, you know, just trying a lot of things yourself. But this one is just amount of this. So, how do we get amount of Na2CO3 in 25 centimeter cube of B pipetted? Do you still remember the formula I gave? 2. That for us to get amount, if you remember, if you have been watching my video, I said it is concentration times what? Times volume. Do you still remember? And the reason why we now divide by 1000 is because your 25 is in centimeter cube. I want to believe that's clear. Is in centimeter cube. If 25 is a dm cube now, I'm not to convert because you should know that 1 centimeter cube is equal to what? 1000 centimeter cube is 1 dm cube. Do you see that now? So it's just like I want to convert now to this. That's what I'm dividing by. I don't know if that is clear. So very, very important. It's just like 1000 centimeter cube in 1 dm cube. 25 centimeter cube will be what? Will be x. Can you see that? So it will now be 25 times 1 divide 1000. That's what brought about this. But the formula for amount is concentration times volume. In as much as the volume is in dm cube. But now the volume is in centimeter cube, so I need to convert. That's how I'm dividing by this. Very clear, right? Okay, let's move on. So the amount will now be, what is the concentration? What is the concentration of this? Look at that. What is the concentration times what is the volume over 1000? Now, what is the concentration of this given? What is the concentration? Let's check. Look at the question. B is the solution of this NO2 per dm cube. Can you see they didn't give you any concentration about your B now? I don't know if you are getting that. So, which means that for me to use concentration times volume over 1000, I need to bring in this. So first of all, get the concentration of what? B. If they have given us the concentration of B, it would have been easier. Maybe they said B is the solution of the 0. If they want to make it very easy, they just give 0.0 something mole per dm cube. Do you see? If they have given that, I can quickly employ this. So I'm just trying to show you all these things. So which means that the amount now, the concentration, I need to what? I need to get the concentration. I'm just showing you. Well, they have given us B is the solution of 0.03 mole per dm cube of a hair. You can now use that. So you need to use that. So if you are not giving the concentration and they ask you for amount, you need to go and get it first. So which means I can now do CAVA over CBVB equals to NA over N. So, but if you are lucky, they can decide to give us the concentration. If they did not give us, we can get it. That's why I'm taking you all through all this long road, so that you understand everything that can be asked and the way to do it. So what is our CA now? Let's quickly go now. What's our CA? That's 0.0684 times what is our VA? That's the volume of RC, 20.60 over what is our CB? That's what we are looking for. Times what is our VB? 25 equals to our equation of reaction. What is the amount of acid to base? That's 1 to 1, right? 1 mole of this to 1 mole of this. So this is 1 over 1. I don't know if we are still together. So from there, we can now have that. Let's make this the subject. So our CB becomes this times this times this divided 25, right? So it's 0.0684 times 25 times 1 over what? Times, sorry, 20.60. 20.60 times 1, then divide what? 25. I want to believe right here. I just tried to go through this long route. They might have given you that to just do your, but you know, I'm just showing you all means. 0.0684, right? Times 20.60, okay? Divide 25. and that's giving us 0.0563. So it's 0.0564. You know, to 3 significant figures. Then I'll have mole per DNQ. I want to believe they are still together. So, but if they want to ease your journey, they can give you this. They will just tell you B is a solution of 0.0564 mole per DNQ of what? Of this. So if they are giving us this, you can just, you know, we cannot calculate our amount. That means you don't need to go through the long route. Since that, but I'm just showing you if they did not give you. So which means stylishly, we have calculated the concentration of B in mole per DNQ. So if they are giving you that question, you know what to do. So I can now do concentration times volume now over 1000. So what is the amount now? The amount will be, what is the concentration? 0.0564 times what is the volume? 25, right? Because they have indicated here 25 over 1000. So our amount now, our amount times 25 divide 1000. So that's 0.00141 moles. 0.0014 approximately 1 mole. So this is the amount. I don't think there's any problem with this. I want to believe this is very clear, right? Very, very clear. So, you know, if they want to make the work easier, they are giving you this. That means you just come here, very simple. But if they are not giving you, you need to calculate it. I want to believe that is clear. Okay. So let's move on. The number of hydrogen ion in 1 dm cube of A. The number of hydrogen ion. Please, very technical. Let me use my other marker so that it will be. Is the red okay? Okay. I want to believe it should be okay now. Okay, now look at this. The acid. They said the number of hydrogen ion in 1 dm cube of the acid. What is the acid first? H2SO4. So let's go. H2SO4. The marker is okay, right? Okay, H2SO4, right? So from here, what will happen? We are going to have 2H plus SO4 2 minus. Which means that 1 mole of H2SO4 is going to liberate 2 hydrogen ion. Why? Because H2SO4 is a dibasic acid. You understand that the basicity of an acid, the basicity of H2SO4 here is dibasic because it's 2. Now look at this. Please pay attention to this. So from here, 1 mole of H2SO4 is equal to what? Is equal to 2 moles of hydrogen ion. I want to believe this is clear. So 1 mole of H2SO4 is equal to 2 moles of hydrogen ion. Which means that, you know, we have gotten the mole of acid, right, in 1 dm cube. And if you remember, we have converted this to 1 dm cube already. So if 1 mole of H2SO4 is 2 moles of hydrogen ion, then we can now have this now is 0.0684 of this will be what will be X. I don't know if this is clear. So from here, we can now say our X equals to 2 times 0.0684. So let's use our calculator again. So 0.0684 times 2. So that's giving us our X equals to 0.1368 moles of hydrogen ion. This is very clear, right? Very clear. Now look at something here. They now say number of hydrogen in 1 dm cube of A. So we know that our Avogadro's constant, you can see it is given here already. So if X is equal to this, then we know that 1 mole is what? 6.02 times 10 raised to power 23 ions, right? 1 mole is equal to 6.02 times 10 raised to power 23 ions. So is 0.1368 will be equal to what? X. Can you see that here? Because 1 mole of any substance is equal to 6.02 times 10 raised to power 23 can be molecules, can be protons, can be particles, can be ion. So from here, you can now say X will be 0.1368 times 6.02 times 10 raised to the power 23. So what will that give us? So 0.1368. If you want to do it on your calculator, just do 0.1368 times 6.02. 0.1368 times 6.02. So that's giving me, x is giving me is 0.824. You see that? Is 0.824 then times 10 raised to power 23 what? Eons. I don't know if that's clear. Which is the same thing as saying, or depends on you, or I can say it is what? 8.24. Do you see that now? Times 10 raised to power 22 eons. It's still the same. So 0.824 times 10 raised to power 23 eons. 8.24 times 10 raised to power 22 eons. So 23 eons here because the 0 is still there. If I remove the 0, I subtract 1 from 23. So this is clear. You know, this is a very technical answer. I just brought this. You know, it's been long I did something like this. So, but I'm just because I've always been doing a lot of predictions. So we can actually have that. So the last one now. The last one. Let me know about this, please. What's the last question? Mass of sodium ion formed in solution during the titration. So that will be the last one now, which is the last question. So the last one now, which is the V, is mass of Na plus formed. Okay, this one too is the same. You know, I just predicted this. We don't know where they'll be coming from. So mass of Na plus formed during the titration. Do you know during the titration, what is the volume of the carbonate, the base we use? Is it not 25? Don't forget I prepared 1 dm cube like they asked us to do, but we used only 25. Do you get that now? Okay, so let's go now. Let's go to the equation of reaction. Our Na2SO4, when we dissociate, it's going to give us 2Na plus SO4 2 minus. I don't know if we are still here. So if this is like this, then let's go back to the amount form. Now look at what I'm doing. Look at this. You know this is a value. Yes, you know this is one value of CB. This is another value of CB. But which one will I use? This or this? The one that is easier is for you to use this. You know why? Because this has already been converted towards 25. We use 25 of, because it's as a result of this that this is formed. Do you see that now? So we use 25 of this, and here already we have used 25. Because if you use this, it means when you get your answer again, you're not going to say this in 1000, 25 will be in what? Do you see that now? So we are using the amount in moles. Please take note of this. So which means I'm using 0.00141. So which means that from this place, 1 mole of Na2SO4 gave us 2 moles of sodium ion, right? So from there now, what are we now going to do? Now say let's have that 0.00141. So 0.00141 will be what? Will be x. This is clear. So our x will be 0.00141 times 2. And that will be what? X will be what? 0.00141 times 2. That's giving us 0.00282 moles of sodium ion. I don't know if somebody is still here. Now look at the difference now. The difference here is now what? They ask us to look for the mass of Na formed. Do you see that? The mass. So, and what is the mass? For us to calculate mass, do you remember? Let's bring in this. Mole is equal to mass over molar mass. Yes or no? Now, I want to calculate mass. Do you see? If we want to calculate mass, what do we do? Mole times molar mass. Have you gotten the mole? Yes. What is the molar mass of sodium? They have given us already. Can you see? 23. So, the mass formed will be equal to what? Mole times molar mass. So that would be 0.00282 times, what's the molar mass of sodium? 3. So our mass, the mass formed, now be equal to times 23. And that would be 0.0649 grams. Interesting. Interesting, right? So you need to go over this. You know, I just have to predict these two because it's been long. In fact, they can add this. You can solve this on your own. Let me see what your answer will be. You can be asked this too. You can be asked this. You just solve that on your own. I'm not going to solve that. So go and solve this. You can be asked the volume of CO2 gas liberated. If it comes out like this, you did not solve it. This is CO2 in the question. Let's come to the question. Do we have CO2 here? Yes. Do you see that? Volume of CO2 gas liberated at STP. So, and what we make CO2 to be liberated? Since this is here, CO2 can be liberated. So, you can put it in the comment box section. What is the volume of CO2 gas liberated at STP? So, this for you. Okay, this for you. So, you can put it in the comment box section. The answer, the volume of CO2 gas liberated at STP. And that's that for you. So don't forget, please, you know, I'm reiterating over this. Don't forget, if the question comes like this, either S2CO3, either Na2CO3.XH2O, either what? H2S, you know, instead of H2SO4, H2S, or you have S2SO4. In all of these, they want us to get X. In all of this, X, X, X. And if it comes like this, I've already explained what to do at the beginning of the video. You need to get the molar mass of all of this compound first. So when you get the molar mass, imagine the molar mass here is 106. You can now look for S because you know this, you know this, you know this. Okay? Imagine the molar mass of this one is 320. You know this now. 23 times 2 plus 12, 16 times 3 plus X into 18. So you can now calculate this. Imagine for this one, it is 98. So you know this, you can get this. Right? If it is like this, S2SO4 probably is 110. That's the molar masses now. You can calculate this. So they are simple questions. They are simple questions. And that's that for this year. That's that wonderful video. Share this video to your friends. Like it. You know, comment. Please, I want to see your comment. It shows that you are exploring on your own too. What is the volume of CO2 gas liberated at STP? Using my same, you know, it's just like, you know, I solved 4 questions. So this is just looking like the number 5 question. So you can put it in the comment box section. Let me see it and I will respond as fast as possible. Tell you if it is correct or it is not correct. I love you guys. This is Chemistry Hangout. Hopefully, by God's grace, our hands have been tight, but you know, we don't want to disappoint our subscribers. We are still trying our best to see how to bring the qualitative analysis. Very wonderful one for this year too. Okay, so stay tuned. Subscribe to the channel. Click on the notification bell so that when we release the video, you are going to be notified. Like this video, share to your friends. This is Chemistry Hangout. We make teaching and learning fun. I love you guys. Thanks for the prayers. Thanks for the wonderful comment. Thanks for the encouragement. We sincerely love you. Till we are going to be coming back on this channel, stay chemically active. I love you.